Harlem Shake.
Solid as a rock. But it flows like water?
What is it? Is it a liquid? Or is it a solid?
Well, it sure isn't a gas. It's oobleck.
Tyler's playing oobleck.
Bloop. You can dance if you want to.
I cannot get my hand to sink in it unless I slow down.
Wow.
Let your hand go down and see if you can quickly pull it out.
Oh, put it in and then... Whoa!
Where are you guys going? What's that? You have oobleck on your fingers?
Some sort of goo.
Hi, I'm Amanda.
I'm Elizabeth.
And I'm Tyler.
Our team has joined forces and we have searched high
And low.
and it seems like no one can solve the mystery. That is until we reached out to a well-known doctor, so well-known everybody in the world has heard of him. In fact, everybody of every age has heard of him. It is the famous Theodore Seuss Geisel, otherwise known as Dr. Seuss.
This story is about a king who got tired of having snow, fog, rain. He wanted something new, so he called his magicians.
Won't look like rain, won't look like snow, won't look like fog, that's all we know. We just can't tell you anymore, we've never made oobleck before. They bowed. They started toward the door. We go now to our secret cave on Mystic Mountain Nikatave. There all night long we'll work for you, and you'll have oobleck when we're through.
The amazing non-Newtonian fluid. What exactly is a non-Newtonian fluid? A fluid that did not come from this guy.
A non-Newtonian fluid is a fluid that changes its viscosity, also known as thickness, under stress. Other, more familiar substances change states from solids to liquid gases when we change the temperature, such as freezing water into ice or boiling it into steam. But the simple mixture shows how changes of pressure instead of temperature can change properties of some materials.
I thought it was a liquid.
I told you
But
it was
it's
a solid.
a solid.
It's a non-Newtonian fluid.
Ooh. It looks like a liquid. It pours like a liquid. But when you run across it, the impact of your feet is enough to change the balance. All of a sudden, you have a solid, but only for a second. But it's long enough for you to move across the top of it without sinking into it.
they face another problem every day: the risk of attack. Despite the best security, inmates still end up with weapons they make on their own, and they're lethal.
You make the wrong move, and if you're not watching out, they can attack you enough to kill you.
You might wonder why officers don't use military-style armor. One reason is they need to be free to react in emergencies. Body armor would just slow them down and make them even more vulnerable to assault. But here at the Materials Research Laboratory of the U.S. Army, they may have the answer. Lightweight clothing that's absolutely stab-proof. And the secret isn't the fabric. It's this stuff, armor in a bottle. Flexible materials like Kevlar are great at stopping bullets, but surprisingly, it's almost useless stopping a knife.
So this is 4 layers of fabric, and this is a type of fabric you'd use in body armor, police vests, even army vests. What I want you to do is take a little swing and go ahead and try to pop through that fabric.
Okay.
Not too big, not too hard?
It went right through, didn't it?
Okay, and if you look...
This Kevlar isn't going to save a prison officer from a shanking.
Oui.
To see why, Eric's put the Kevlar swatch under a microscope. You can see how the spike pushes around the tough fibers. It just slides right between them. So no matter how tough the fibers are, a sharp blade can just slip through. So fiber strength means zip when it comes to a shank.
Just stab...
But
this
add
way.
some
Right
liquid
there?
armor to fill the gaps,
Really give it a good one?
and it's a different story.
It didn't puncture at all. I mean, it made a dent, but it didn't puncture.
No, it would hurt pretty bad, but you're not going to have a spike going through your vital organs.
Right.
This super strong goo is called shear thickening fluid.
Well, this actually has 2 parts in it. It's a liquid and a solid combined. So the liquid is this thing here. It's called polyethylene glycol. It's a polymeric liquid, very safe. It's kind of like antifreeze, but you could actually eat it. But you combine this with a solid phase, which in this case is a powder. It's silica powder, so silica is glass.
Right.
So, how does this stuff work? The billions of silica nanoparticles, more than 100 times finer than human hair, mix easily and evenly in the glycol. In a liquid state, the particles have a weak molecular surface charge, so they don't clump together to form a solid. But when an object impacts the liquid, it changes radically. The object's kinetic energy forces the particles together, and they lock in a lattice with strong chemical bonds called a hydrocluster. The liquid becomes as hard as ceramic for a split second. Then, when the kinetic energy is spent, the bonds release, and the solution becomes liquid again. It's truly amazing.
So I want you to push in there real slowly with that rod. And what you're going to see is there's not much resistance. It's kind of like a liquid.
No, it's going down to the bottom smoothly.
Okay? But if you yank in a big hurry on it, yeah.
It will not let go.
When I apply strong kinetic energy, there's no way I can push through. As soon as I stop pushing, the silicon particles let go. Tough as ceramic, but still a liquid, which means it soaks right into the woven Kevlar. We're looking through the microscope again. This time, I'm trying to pierce some treated Kevlar.
The fabric's moving, but there's no windowing. There's no separation of the fabric.
So it's a big improvement on the raw fibers. But this technology is meant to save real lives in a tough world. But what about a brutal stab from a big bad guy? So we're going to drop this stainless steel spike from 8 feet. That's equivalent to a blow from someone weighing 230 pounds.
All right. 289, 3, 4, 5. There it is. 3, 2, 1. And it did. It bent. Wow, it really bent.
Even a massive blow like this doesn't make it all the way through. The shield of clumped silica particles held strong.
And there is no hole whatsoever.
The powerful kinetic energy made the silica particles lock tight into a ceramic barrier. Okay, I'm impressed, but how big a blow can this stuff really handle?
Now, remember I promised you something a little special.
Don't kid yourself. This hunting bow is no toy.
It'll produce somewhere in the vicinity of 175 feet per second.
Right.
It's aluminum arrow, feather fletched, and it has 125 grain bullet field tip.
Okay.
In other words, this is a serious weapon. It could kill a bear at 20 paces.
Be careful of the ricochet.
First, I want to see what it does to untreated Kevlar.
Nice shot.
How far was it?
I think it's about 68 inches.
Yeah.
Now let's see what happens to a vest impregnated with liquid armor.
Couldn't get through this.
Well, we do lots and lots
Remember,
of testing.
this is a steel-tipped hunting arrow traveling at 170 feet a second. Our high-speed camera reveals something incredible. The arrow bounces right off.
In this case, the shear thickening fluid is holding those fibers in place, won't allow them to slide out of the way, keeps the arrow from getting all the way through.
Right.
And Eric has other applications in mind for this amazing goo. Just imagine what treated gloves could mean for rescue and healthcare workers. No more needle sticks from dirty syringes. But getting lightweight, stab-proof uniforms into the prison system is still Eric's priority. These guards risk lethal attack every day, and liquid armor is life-saving technology.
There's always that threat. If that threat exists and there's an item out there that can protect us, absolutely. As long as it's somewhat lightweight, something you can move around in.
Con los terroristas.
You can do the Harlem Shake.